Right. So today from Pell Consulting, welcome for the podcast. And it's myself, Pasha, and Ken.
Hello.
And we're going to talk today about sort of the visual sense, how it connects to your mind or the brain, and how we perceive the world using our most commonly and most prominent sense, which is your visual sense. And we'll see where it goes from there and get into the details and see how it relates to our lives in general and day to day, as well as, different age groups and how it changes and evolves over time in a person's lifetime. So,
We're also going to go a bit deep into the brain structure as
yeah,
well of the visual cortex and how vision works in the eyes, things like
cool. Yeah, I mean, that's content that I don't know at the moment. I'm going to learn a lot as well. And so, yeah, to get started, what is the visual sense? What is exactly visual?
Yeah, so visual sense, it's might be feel weird to say because it's so obvious. Visual sense is something we see from our eyes, right? So the light information, light all around us comes and hit the retina, and then the retina, that information changes to the electrical signals and then that goes towards the brain, and then the brain sort of understand that information and try to perceive it. And so it creates the visual experience that we see all around us. And then there's color sensations from that. So some people see different colors, and some people, I mean, everybody sees like red, blue, and green, but some people don't see one of those colors, like colorblind people, right? There's color sensation. There's different kinds of perception of edges and understanding of objects, things like that. Yeah.
Cool. Is it true that women can't be colorblind, or is it just rare?
It's rarer for them.
Right.
Yes.
Why is it so?
Yeah, because color blindness come from the sex chromosomes in the DNA.
Okay.
So
Yeah, of
men
course.
have one X and one Y.
Yeah.
Women have two X's.
Yeah.
Right. And then the colorblind genes tend to be recessive, meaning that if there is a dominant version of the gene, it takes over, and then so that you don't get the colorblind at all.
Right. So
Yeah,
it's easily suppressed, basically.
It's easily suppressed.
Right.
And usually on the X chromosome. So when women have two X's, so if one X is normal vision and the other X is colorblind vision, so it gets taken over by the normal one.
Okay.
So it tend to be not happen. But for men, if we get the colorblind X from our mother,
But there's no another X to suppress it. Right.
So men have more common. There are, I mean, women who have colorblind have both X's.
Both X's. Okay.
Yeah.
Okay.
Are colorblind.
Is it as simple as both parents are colorblind and it just means you'll be colorblind, or is it still?
It's a chance.
It's a chance,
It's
right?
a chance.
Okay.
Yeah, with DNA, there's always probability chances.
because it's like split and everything.
Yeah,
Okay,
and it's not
cool.
just colorblind. It's different kinds. There's a green colorblind. There's red colorblind.
Right. Okay.
Tend not to be blue one, but usually red or green.
Okay.
Tend to be colorblind.
Okay.
Yeah.
So, what's the most common one of color blindness?
Green colorblind.
Right.
Incredibly.
So if someone is colorblind towards green,
Yes.
does it mean I mean, I kind of roughly know the answer, but I just want to put it out there. Does it mean you can't see things which are green, or do you see a more generic or the wrong color or something like that?
They see a different color.
Right.
Altogether. Yeah.
So it's not like
they just don't see
not a
green.
default of gray or something like that.
No.
It could be something which is not. I mean, I can't say accurate because I perceive green in a certain way. It doesn't have to match everyone else's, but they're not going to notice the shades of green, I assume.
Yeah.
Right.
Yeah, they don't notice it at all. Yeah, but they see other colors instead.
Right.
So our basic colors in our retina, the cones, they're red cones. There's one for blue, there's one for green, and so from those three combinations alone, we see millions of colors.
Yeah, of course.
Right. So all the different concentrations, or not concentration, sorry, different intensity, and different wavelengths.
Yeah.
So those cones detect.
Yeah.
And so that's how you see different colors. And so like million different colors. So because they have no green, so they still have the other two. So they still see fewer combinations of colors. And then not only that, there's another weird thing about perception and consciousness is that people who are born colorblind, they assume that everybody see the same.
Of course.
Because they don't know that they're actually
Of course.
colorblind. They're like,
Yeah.
I mean, like, yeah, obviously this is not. What
Yeah,
is
yeah.
green anyway?
Yeah,
What
yeah.
is red anyway?
Yeah.
So if you explain redness or greenness to someone that are colorblind, you just can't.
Right, because they
don't.
might perceive it as the same color or indistinguishable
Yeah.
colors, basically.
Yeah,
Right.
exactly.
Okay.
So
Cool.
it's
Very
only
interesting.
through actual tests that they start
Right,
to see
yeah,
the
yeah, yeah.
differences. Yeah.
So, are there these kind of glasses that you can buy which can do something to the light so that people that are born colorblind can now suddenly distinguish those colors, which they usually
No,
can't?
no.
No? Because I've seen some videos where people are getting these glasses and then now they're able to notice the vibrant greens of the trees and stuff like that. What about those?
Marketing too.
Really?
Yeah, they tend so how do I say it? It's on level on the perception itself, right? So you can it's not green the way we see green. They might see it differently still.
Right. They
but
might,
will
they might
notice.
see a new perception which they haven't
Yeah, true. Yeah, similar to new
felt
perception.
before or noticed before. Okay.
Yeah. So if they lack the green element of their cones, they will never see green. Basically,
Of course. Yeah. So
Yeah.
I'm not saying they will start seeing green.
Yeah.
I'm just saying allowing them to basically notice the difference between two colors compared to before when they couldn't distinguish between two colors. Not that they will start to feel a color they don't have the cones for, but rather just being able to amplify another color to look like something else. So I think those kinds of glasses exist, but yeah, of course you can't change the biology of your eyesight. So yeah.
Yes.
Cool. So you mentioned eye works by light hitting your iris or retina. You said
The
retina.
retina, yeah.
So what's the main sort of structure of an eye? What is the main structure?
So the eye is mostly hollow, but it's filled with liquid. So most of it is filled with liquid, and then the retina is the very back of the eye.
Right.
So there's a little small blind spot. There's actually that area of the area you can't see.
Right.
It's actually a blind spot. So it's literally the brain comes to the retina. So the retina is basically the brain coming out to see the world, basically.
Right.
So it's and then the light hit the retina, and then there's on the retina itself there are different rods and cones. So rods are usually on the peripheral side of the vision, so on the side, and then the cones are much more on the front of the vision.
Okay.
So the rods are for low light. So when you see in low light conditions, when you're at night, when you see black and white vision, so that's more rods.
So just to inject this information here, I mean, it makes sense that the peripheral, the low light vision is on the peripheral because when it's super dark and if I look directly at the clock, I can't see the time. But if I look to the side of the clock, then I can see the time. Right, that makes
the
a
rods
lot of sense.
Sensing it.
Right. Okay.
And there's
That makes
evolutionary
sense.
reason for that because at night or low light condition, that if there's chance of predators moving in the forest, we need to be able to see it in the side. So because that's where usually danger comes from.
But why wouldn't you want to be able to see it in front of you as well?
Yes, you can, but the front element, the front vision, there's the retina, the cone where it is, it's very high quality vision, and it's very very small. So compared to how wide the visions is,
so just like a camera, if you basically want to have a grainy, bad quality photo or image quality, you can see a lot in the dark. But if you want to see a good quality image, you will need a lot of light. So
that's right.
I guess just like that for us as well. I mean, it's physics at the end of the day. So for the high quality central vision, you do need that extra light to be able to use that sensory organ.
Yes.
But for the rest of it, which is kind of peripheral, it just works out in lower light conditions already.
Yes.
Okay,
so if you think of peripheral vision is evolution for our prey instinct.
Yeah.
So we run away from predator.
To be aware.
Yeah,
of
and
more
the
than
front vision is for hunting instinct.
Right.
So when we hunt other prey, we need to see that minute differences, color differences.
Yeah.
Right. So our high quality little vision here at the front, very little sort of range of it, but very high quality. So we assume that it's very strange, right? So we assume that our whole vision is high quality and smooth dynamic, but reality is not.
Yeah, because
then,
I can see that there, but it's definitely not high quality. I might feel it's high quality because when I want to see it, I actually look at it. So
that's
right.
I
think everything is
you're
good
moving
quality.
your neck and you move around and see it.
Yeah.
And the funny thing is, I noticed this effect even more because in virtual reality headsets, especially the one PSVR 2, the one used for gaming that came out. So they created a program, automatic program, where they render part of the game at the point where you're looking with your eyes, with the high quality vision,
right?
And then so you don't notice it when you're in the high quality headset. You actually don't notice that it's doing that. So everywhere you look, it feels high quality vision, but it's only doing that for a small.
So is it actually
range
tracking
of it?
your eye movement?
Yes,
it
is.
Okay,
and actively creating the image based on your eye movements. But if you look at on the TV screen of what you're seeing,
if someone sees, it'll be like, why is it all blurry?
Yeah, most of it blurry, but a little point is it's, and you can tell, you can actually make someone scared by saying like, "Are you looking at there on the TV?" Like, how do you know? Yeah, because that part of the area is clearer in the TV screen. Cool. It's pretty cool. Okay. Yeah, so they design the technology based on how the vision works
already,
and then also it saves energy for the energy.
I mean processing power.
Exactly. Yeah, so that's really cool.
Cool. Yeah, that's awesome. So, well, going into the technicalities of it, we can obviously see all of the typical colors if you're not colorblind, of course. So you can see, all the colors of the rainbow, which is, the entire spectrum. We can't really see any other colors outside of that electromagnetic spectrum. We have infrared and ultraviolet.
But some animals can see it.
Of course, yeah. So that's what I was going to get to, which is, there are animals out there who see that, and, it's sometimes very interesting, and I get very curious how they might be perceiving it. Do they just see another color, which I can't imagine?
Yes.
Or do they have some other way of sort of, mentally imaging that or something like that? And it goes back to a recent thing I saw about this, where a person actually had a head injury and they lost the connection to some part of their brain where they could no longer visualize what their eyes are seeing. So the eye organs are fine, the connection to the brain is fine, but the part of the brain which makes you see it in your mind's eye is no longer functioning.
Right.
And so when they got this person to sort of walk through a corridor and they are 100% unable to see anything, but there are obstacles on the floor, they are automatically just navigating around it. And when they ask the person, why did you walk there and not just straight? I was like, I didn't do that.
Or like,
they just
I just felt like doing it.
Yeah, it's just an involuntary feeling. But in reality, the brain is just dealing with it the way it was doing it before. But the only difference is they can no longer see the output anymore.
Yes.
So that's very interesting. And it's same with people who are born blind. They still visualize things based on either echolocation, if that's what they learned, or being able to touch something and feel something or hear something, and they most likely end up automatically creating an image of the world around themselves, even if it may not be even close to how I see the world around me.
Yes.
So that's it just proves that how built around the visual sense mammals typically are.
Yeah, very much. So for colors, like different other animals can see different colors. For example, butterflies can see ultraviolet vision. Right? And some birds can see ultraviolet vision as well. So the way they see the world, they see more. So ultraviolet it's blind to us. So we cannot. It's naturally on when we see the sunlight. It's in the sunlight.
It's in it,
but we just can't. We're blind to it. We just don't notice it.
Yeah.
So the reason why some animals,
I think it's the wrong word to say notice. We just cannot detect it
at all.
Basically.
Yeah, cannot detect it. Yes. So the reason why some animals are evolved to it because ultraviolet shines on flowers, for example.
Yeah.
So birds,
it's very related to vibrancy and glowing.
It glows on. So you see for insects or birds that rely on flowers, they need that vision to navigate it. And then for infrared vision, right, it's usually for low light condition.
Low light and heat as well.
Yeah. So if they need to hunt at night,
Yeah.
for like seeing.
So
heat,
we have like heat
heat
wipers.
It's basically
and
heat
stuff.
signature. So
Yeah.
when the soldiers use heat,
thermal
infrared
vision or
thermal
something.
vision. So
Yeah.
basically that's what they see.
Exactly.
Basically.
Yeah. Absolutely.
In terms of that blind one, that very interesting. So
Yeah.
so the reason why that happens because our eyes is connected to two parts of the brain. So subcortical part and then the cortical part. So subcortical goes deeper into the brain stem, and then so the deeper like down here, and then
Right.
and then the cortical goes toward the back of the brain, the top back of the brain. So the top back of the brain is where we see the visualization,
Right.
the image, the perception of our vision, the
Yeah.
feeling, the conscious experience of it.
And that's why you get blacked out when you get hit in the head in the back of the
That
head.
basically, yes, exactly that.
Yeah.
And then the subcortical one, it's very beneath our conscious, and allow us to quickly navigate in our environment. So we still use that vision.
It's basically processing the incoming data from your eyes, essentially.
Both is processing, but they're
Right.
different things. They
Right,
process different things. So one is processing on a conscious visualization, pattern recognition,
Mhm.
and then the lower end is processing more navigational, more time based, and also
Right, okay.
for able to obstacles and things like that. So able to understand shapes as well. So
Right.
yeah, and when one part of the brain got destroyed or injured,
Damaged,
so
yeah.
the damage and like the visual part of the brain, visual cortex got damaged, but the subcortical is still working.
Yeah.
So they're still working. So the
Yeah.
reason why they still get the feeling of why they should avoid the
Yeah,
obstacles
yeah.
because that subcortical rely on feelings and emotions.
Okay.
Yeah. So
Okay.
that's why they get the feeling that they should move around, but even though they don't consciously perceive the vision.
Okay. Cool.
Yeah. So it's a very, very incredible system.
Cool.
Yeah.
That's awesome.
Yeah.
Yeah.
So,
So yeah. Go on.
in your life, like how do you use vision since you were young, and then how did you learn to use vision since
Well,
you were young?
I kind of look at that as a trick question because nobody really learns to use their vision, right? I mean, it's
so
kind of
obvious.
just,
Yeah.
it's kind of just something you are born with if you're privileged enough to have your vision working.
Yes.
And I'm grateful for my vision. I can't imagine not having it. It's a very scary thought.
It is.
I know a few people personally who one of them never had it ever, like not even 1% of it,
Okay.
and
They're born without it, basically.
completely, and they are. It is crazy how, like, it's hard for me to imagine. It was hard for me to imagine being as proficient as I am in my daily life
Yes.
without vision.
Yeah.
But when I met that person and I actually worked with him,
Oh, okay.
basically he was a colleague in a software development place, and he's a software developer, and I mean it was a remote company, so I worked with him remotely for a while.
Sure.
But when I actually physically met him for the first time, it just blew my mind how he is as proficient as I am in my daily life and programming and working with others and meetings and coding and everything. But
that's incredible. So are they using like a blind computer?
No, they use a
computer
normal
made for-
computer with lots of tools installed on it,
Okay.
and their phone as well, lots of different tools,
Yeah.
and so it was just crazy to see that they're like getting all the same level of output, and in most cases better than me because he just had more experience than me. He still does,
Yeah.
but just the workspace as well as the working methods are completely non-intuitive to me.
Of course.
But
yeah.
of course, completely part of life for him.
For him, yeah.
And so, everything from listening to messages, and listening to emails, and sort of just navigating with the keyboard because it's just obviously going to work better. You can't really do the mouse thing because you can't see where the mouse cursor is going.
Got it.
But you know how many clicks to do and what to do to move the focus of your selection with the keyboard and mouse.
Interesting.
Keyboard, not mouse. And
Yeah.
so, obviously, it took him a long time to do it, but
once you
now he's
master it-
just as fast as me, and I can't even begin to do things on my computer without the mouse.
Yeah. Yes.
But it's just the way he's learned it, right? And people who, like, for example, I used to play a game called Battlefield 3 with a friend of mine, and this was back in like 2011, 2012, actually 2011, and we used to play first-person shooter games, right? And so in sort of in shooting enemies and that kind of thing, we used to play together as a team, and I was really good at certain things. He was really good at certain things, and he was really good at very precision sniping, for example.
Got it.
And so after about 4 years or something of playing with him and completely accepting the fact that he's just way better than me with that specific mechanical skill than I am.
Yeah.
And I was pretty good with the mouse. I used to be, at least. But after about 4 or 5 years, one day I realized, just in talking, that he used a controller the whole time.
Oh,
He was playing on PC,
right,
but he always used a controller.
Yeah.
And I could not believe that he can achieve that level of precision when, like, if I sit down to play a game with a controller, I feel motion sick because of how difficult it is to have my motor functions work.
It does, yeah.
With the camera move and the
especially
movement.
for shooting games, mouse and keyboard is way more intuitive.
For me too, like, I just couldn't believe that he did that, and just purely because he's used to it and his motor functions are built to just work with that accordingly. And so yeah, it's just crazy that the mind is so adaptable to whatever the situation is. I mean, okay, you lost your eyes, okay, let's just deal with it, just go with it.
Life goes on.
Yeah, and usually the people that slow down or have a difficult time is mainly because of their mental state, which actually slows them down a lot, right? The actual brain, the technical brain itself, is very adaptable. If you just force it to do something or handle something, it's just going to start doing it, slowly.
Yes.
So
Yeah. I mean, it's not limitless, but it's highly adaptable. Yeah. For like,
yeah, I suppose. Yeah.
Yeah. For people who are born blind,
Yeah.
and they actually don't dream in vision at all. Of course, I mean, obviously.
Wow. Okay.
Yeah. So they dream in sounds or smells and things like that. So they actually don't in their dreams. They don't get chased by people. They hear the chasing instead, things like that, right? So other sense, and also we call the part, the back of the brain, the visual cortex, is because it's correlated with vision, right? It's not necessarily only for vision.
Right.
So the visual cortex is used for pattern recognition, is used for understanding of edges and shapes, right? Things like that. So even if you have lost the vision, the eyes, for example, the visual cortex, you can still use visual cortex. The brain use it to understand patterns. So the visual cortex is still active in a blind patient.
So is it wrong to call it visual cortex, and do we just call it visual cortex because visual tends to be the most usually accepted thing in there? But it does actually process all senses and patterns in all senses?
No, not all senses, but like it processes different levels of patterns, different levels of visualization. So you can still visualize even when you're blind.
Okay.
Right. So people who had vision and they became blind later in life,
of course.
they can still retain the ability to visualize, and so they can still understand the pattern and visualization, and so it still works. So if you have the brain sensor on it, they're still active even though the eyes are not working, right? So it's a naming convention, right?
Exactly,
I mean, the brain is highly adaptive, and also it has I call it a not I call it, but many neuroscientists call it neurorecycling.
Right.
So neurorecycling is a term where the part of the brain that's supposed to do something is doing another thing.
Supposed to do something in the typical construction of a mind. Yeah.
That's right.
Yeah.
But it's doing something else, another activity that we have taught them to do.
Yeah, either due to a change from birth or due to damage or injury or
cultural adaptation. Or learning new skills.
Okay.
Yeah.
For example, what? I mean, I understand what you say by cultural adaptation, but what would be an example where the brain literally started doing something abnormal with part of the brain due to culture?
So for an example I would give is color names in culture and language, right?
Okay.
So in English language, we have all the different names for red, green, indigo, turquoise, things like that. But some other culture, like in Russian languages and in Burmese language, there's new words for a different shade of color, like another shade of blue, another shade of coral. So they have a new word for it, and then if people use that often, if we don't have the word, we don't notice that color range, right? We do see it, but we don't notice it, so we don't pay attention to it. But it has a name. If that color has a name to it, in some cultures, they pay attention to it, so they see it more brightly. So the attention is more prominent for that color that has the name attached to it, for example. Okay. Yeah. So culture and language can somewhat shape the brain. So it doesn't make you see new colors. It just makes you pay attention on a perceptual, on a subconscious level, to the colors that the culture teaches the people that it's important to learn that, right, color. Yeah. So if, let's say, imagine this, right? If we have no word for red whatsoever, we will see the red. We just wouldn't pay attention to it. We would just like let it out of our sight. It's just like green. It'll be like green plus something. Yeah, it'll be like that, right? Yeah. But red is universal across all cultures, because we need to see perceive red because of blood, things like that. Yeah. So and also attraction is very linked to redness as
blushing
well. Blushing and when you wear red color as a clothing, you become more attractive. Things like that. So vision is highly connected to emotional systems, right? So attraction is one of them, right? So colors, and also like if someone find people attractive, so there's proportional ratios that we're figuring out that for women and for men that are highly attractive by most people. When you see them, they tend to have attractive proportions. So it's evolutionarily we have our vision pick out, and when we see those attractive people, it gives a pleasurable sensation when we see them, for example.
Cool. Going a bit back to where we talked about a little bit, you talked about how the central high definition or high quality spot of our vision is due to our sense of predation or predatory sense.
Yeah, hunting.
So hunting. So I understand that animals that typically have their eyes on the sides are typically there to be prey, essentially. Usually.
They evolve to notice
more
visual range so that they can run away from danger.
Basically. Not just run away, but also notice it in the first place.
Yes.
Notice movement, something creeping up on you. Excuse me. So, and of course, we have our vision, where we not only have the high quality spots in the middle, but we also have binocular vision, which has lots of overlap in the middle. Which essentially doubles the quality in there.
But it also creates depth perception.
Depth perception, of course.
Yeah, which is actually a unique feature of our vision. That it's when some people who are born with just one eye can never understand what depth perception looks like. So there is a research, like a neuroscientist. So she always had one eye, right? And then one of her other eye is not. She wanted to do a surgery so that it would start working. And then when she had that eye healed, and then when she see the depth perception, she understood so when people try to explain to her what the depth perception is, that she doesn't compute it in her mind, because she never seen it. But once she's seen it, the way she described it is like things pop out at you, right? So the depth perception, like when we see objects around you, it has the feeling that's closer and further away. But when you don't have depth perception, it all feels like a flat 2D. And it doesn't. There's no richness of that closeness and far-awayness.
There's a very interesting story I came across related to this, and the mind and how it sort of creates the image of the world around us. Where there's this tribe which lived in sort of the deep rainforest, and it is an extremely dense ecosystem where there's trees everywhere. Right? You can't walk for like maybe 3 or 4 steps in one direction before having to turn because there's a tree in front of you, right? And so they lived from their birth all the way until they're adults in that kind of environment where you're just surrounded by trees at a max distance of maybe 10 meters if you clear the area, you know? So these people actually were found, and when they understood the language and everything, and then when they brought some of them outside of the forest, they were perceiving faraway people as small people, and they were freaking out because they didn't understand the concept of something being far. Everything is either here or there, but that place doesn't exist. That just means that's just a small human over there. That human is just here. It's just small. You know, so their brain couldn't fathom that something can be that far. You know? So that's just because the mind was just built to handle a particular type of scenario all its life. So it's just a machine. It's just going to connect those neurons and can make those connections and just perceive everything with that world view, basically.
It's a shocking sensation for them, reaction for them. But they will learn to see it over time.
Of course, that's
in about a week, they will learn it to see it. But so we have an emotional connection to distance of objects. So when people or objects are really far away, we tend to have a more abstract connection to it, like it's just something out there, sort of feeling. But the closer it gets to us, so imagine like you're walking on the sidewalk, and then you see a person coming to like walking towards you. But if the person's really far away, you kind of don't notice them. Like
even you might see them.
You might see them, but you don't really care about them.
There.
But the closer you get, you start to have that connection. Oh, there's a person. Or is that person a male or female? Like your mind start to
notice
the details, and then even have an emotional reaction towards them, right? I mean, is it apathy or is it attractionness, or is it like, oh, is this someone I used to know, or someone, you know, like those information start to become more salient. So the closer it gets, so it also works for objects. So when objects are really far away, you don't really care about it as much. Like, oh, it's somewhere over there. But the closer you get towards the object, or the object comes towards you, and then you start to have more high-level processing towards that stimulus.
Okay, cool.
Yeah.
I mean, when we were kids, we used to have these glasses which had mirrors in them to see everything upside down.
Oh, yeah.
And so of course it's very disorienting when you put it on. Can't do anything. But it once I heard that if you keep it on for like 3 days, then you'll start seeing everything upside down or something. Which I know they've done these experiments and that happens. However, I didn't have the guts to do it for that long because I was scared I'd get stuck like that. So I did keep it on for a few hours, and I didn't see things upside down, but I definitely became really comfortable with it, and
you learn to adapt it.
I became able to handle it rather than freaking out every half a second. Everything I look at, oh, that's new. No, now it's actually okay. That's how things look. So that's interesting. So I mean, it's definitely very adaptable, and so speaking of adaptable, I was saying that the mind is super adaptable, and that whatever you force your mind or brain to do, it'll kind of just figure it out. You mentioned up to a limit. What are the examples of limits?
The obvious example is we can't see new colors.
Of course, I'm not talking about supernatural or unscientific things, but are there any limits? Like, for example, there's people who have brain injuries or tumors where half of their brain is removed, right? So one of the hemispheres, I think it's called a hemispherectomy or something like that.
Yes.
But so of course their brain then has to sort of grow into the other side. When that happens, does it look at the original DNA and make the missing hemisphere with its original missing things, or would it kind of just one side would grow? So if you had like the left side, then would it just become a big left type brain, or would it start to create a more right side even if it was removed?
It will not create new if it was removed.
Right.
Yeah.
Right.
So at all, because the brain, new neurons don't grow easily
Yeah,
in the
of
brain.
course.
Not
Yeah.
like the skin cells. Skin cells grow easily, but
Yeah.
brain cells don't.
Heart and brain,
Yeah.
they don't.
They
Yeah.
don't. Yeah. And the reason why it's the person start to retain, so different parts of the brain specialize for different kinds of perception, skills, and things like that. So when you remove one part of the brain, let's say you remove the left brain, so the left brain is to do with like logical understanding of
Yeah.
things, language perception, facial recognition,
Yeah.
and all those different elements, the very specialized skills. Let's say
Yeah.
you remove it, you lose them all
Right.
in one go, right? But
Yeah.
then the stimulus is still there, so you still see faces around you,
Yeah.
but you just don't notice them or don't care about them anymore. But then you can learn to process those images again by the right hemisphere. So the right hemisphere take on new tasks, right? And then new processings that the left used to do, but no longer do because it's gone. So it's that the brain adaptable in the sense that it takes on previous tasks that are specialized in some other areas, and now this other area is not doing it. It's like a parallel system start using previous processing power to itself towards it. So that, but the thing is, like, it's not perfect because it's not as specialized as the left brain, for example. So it will retain it, but it will not be as good as before. It will just be a worse version of it.
Right. So
yeah. So there's a book by Jill Bolt Taylor. She wrote about hemispheric differences. So she wrote about when she's a neuroscientist, and it's incredible because she had a stroke while in her professor office.
Oh,
and
okay.
she's noticing her own brain changes while she's in the stroke.
Okay.
So you should read her book. It's
Wow.
amazing.
Okay.
It's called My Stroke of Insight.
Okay.
Very, very amazing book. And she wrote the second book as well. So her left hemisphere start to fail because the blood is flooding into her left brain. So she started losing like specialized, like left brain skills, like numerical recognition. So like she started to call someone that she's having a stroke, but then she look at the number, she doesn't recognize them anymore suddenly. Right, because that part of the brain is now flooded with the with the blood, and then she and then she managed to call, even though someone picked it up, but she started speaking. So she has an intention to speak, but the word don't come out anymore, right? So that the language processing of like speaking and thinking are different parts of the brain as well. So she started noticing these, and then she realized that when she was fully in that stroke state, her awareness of the past and the future disappeared completely.
Wow.
Because that's what the left brain keeps you track of. It keeps you track of tasks as the future coming, your own past. So the right hemisphere is very much in the moment hemisphere.
Right.
So now she's basically feeling like a nirvana sort of enlightenment feeling when she's fully in the present, and then the whole universe connected to her, that kind of feeling. So the right hemisphere managed that sensation. So now the left is gone. Now she's really much the right is taking over completely, and so she's in that, but she can't do anything anymore, right? She's not because of the stroke, but because she can't function in society anymore, because in society we need the balance of those two brains together, right? And when one fails, if the right hemisphere fails, we won't be able to like understand gestures, we won't be able to understand cultural differences, right? Not cultural difference, but sorry, the context differences. And cool. And then after she recovered from her stroke, about 8 years later, her some of the part of the left brain started to come back online, and then she started to feel those skills come back again. She started to be able to speak again and talk and understand mathematics again, etc. So it's unbelievable, and also linked to vision as well. So her vision. So in our vision, right, we see edges, boundaries, and borders and lines, and that so for example, like our body starts or start and stop at our skin. So we see our body shape around it, and then we see the shape of objects, and then one object's different from another object, right? And that is actually created in our brain. It doesn't exist in reality per se. That understanding of one thing separate from another, and that is maintained by the left hemisphere of the brain, right? And the right hemisphere of the brain see the background context of the vision.
Okay.
right? So the context, like the in between, the space in between the objects, is the space in the background, and space where you see the interconnections between different objects. So when you're under the right hemisphere dominance, so your vision, your how to say it, the object of yourself meld towards the outside world. So the one right when you have left hemisphere stroke, you see your body sort of no longer have any boundaries
Wow.
anymore. You
Okay.
literally don't see any boundaries anymore.
Wow.
And then it's difficult to imagine
Yeah.
that now,
Yeah.
even for
I
myself.
can't. Yeah.
But yeah, so the even vision changes based on different hemispheres and how they process them. Vision.
Okay.
Yes.
Cool. Wow. So when it comes to, of course, something like losing half your brain or removing half your brain, the other half, or the remaining brain part, essentially starts to take up certain tasks that it is not specialized to do, but tries to do it anyway, kind of thing.
Yes. Yes.
So when a person is born, is it basically because of their DNA and stuff where, the brain is built with certain parts already predefined to be specialized in certain things?
Yes.
And why is it in the same kind of place for each person?
Right. So this is a complex thing because
Okay.
how to say it? So the different part of the brain specialized, but it needs the outside stimulus for it to activate it.
Right.
Right. So think of it this way, right? We have an affinity for language, but that window is very small window. So
And if you miss it,
if you
then
miss that
it's gonna be
that
hard.
window,
Yeah.
not hard. That child will never learn language ever again. Right. So
Okay.
so that's between around 1 year old towards the 4 or 5 year old.
Okay.
So that's a range where that child needs to be immersed in an environment where there is language.
Okay.
Right. For example, where a Tarzan, the Tarzan cartoon,
Mhm.
he let's say he grew up in a forest, and Tarzan grew up in the forest, but then he can speak just a few words. He just can't
Yeah.
speak like a string of words and
Words. Yeah.
sentences,
Yeah.
right? And so the brain specialized for that needs to be in a language environment for it to activate it, so for it to function it.
Right.
So it's a combination of nature and nurture. So the DNA, the instinctive specialization, as well as the environment stimulation combination, and then,
Right.
only then it activates.
So
So and similarly, if a child with vision is left in a dark room since the time it's born, it's very unethical. Please don't do that. So left in the dark room for most of his youth, let's say, and then that child comes out of that dark room, that their eyes will no longer function, for example.
Right.
The visual part of the brain will no longer function.
Right.
Or function
Theoretically. Yeah.
or as function as a healthy person. As a child would.
Right.
Yeah.
And could they learn to use it?
They could, but it will not be as a healthier child. But
Of
it'll be
course.
very, very worse version of it. They'll
Right.
teach like some colors, some structure, some objects, but they will not be able to perceive it, vision
Right.
anymore.
Okay.
Yeah.
Yeah, because we take for granted that there's a chair there, there's a plant there, but I'm
Yes.
saying that because I can see it and my mind is processing that electromagnetic light
Yes.
and then creating that image in my head
Yeah.
of that being there with the
Yeah.
binocular vision and depth perception.
Yeah. And separate that object from the environment.
Yeah, and not say that's part of the wall, that's actually on the floor, a separate thing.
Yeah.
So if I never saw anything, I wouldn't know what to make of it. Even if my mind saw it, my mind wouldn't have ever created an image of anything because it never used the sense for anything. Cool.
That's right.
Well,
Yeah.
not cool, but I get that. Okay.
Yeah.
Yeah.
So
that makes a
let's
lot of
say
sense.
someone who became blind, started to become blind, and then they had an eye surgery, and then they can see again, right? So and there's a time delay. Like let's say that person become blind for about 5-6 years, and after surgery they can be able to see again. But because they've been blind for about that long,
Yeah.
and when they're able to see again, they actually cannot see immediately. They need to be still in the hospital. They just can't be out yet
Yeah.
because they cannot understand. So they will see light and brightness but they won't be able to see objects. So they
But-
just won't.
So I'm
Pick them
guessing
out.
that is the hardware might have already kicked in and
Yeah.
started working
Mhm.
perfectly,
Mhm.
but the software hasn't started using all the data correctly yet.
Yeah.
Because for so
Software
long,
is also hardware too. The
yeah,
part of the
but
brain that
but what I mean
process
by that is
yeah.
it's not neuron wise, it's not wired to do that perfectly yet.
Yes.
It was at one point,
Mm.
but it's either because how the way our memory works, if you don't use something, you lose it basically,
That's
right?
right. Yeah.
If same with your muscles as well. And so you either lost, that person would have either lost those connections or most likely repurposed it to do something else, because that's what the mind is going to do if it suddenly lost its vision, isn't it?
Yes.
So it
That's
would
right.
have repurposed that part of the brain to, okay, we're not getting any senses here anymore, let's just start doing something else with it, basically.
Mhm.
To, okay, cool.
Yeah. So
Yeah.
for yourself, I want to ask: do you think in words or images?
Images.
Primarily.
It's well, images is my default answer.
Yeah. What kind of images?
I haven't really
that you think?
sat down to think about this question too much.
Mhm.
But yeah, I mean, okay. The reason I say images is not because I strongly think I think in images, but because I strongly think I don't think in words. Okay.
Okay, I
I
see.
definitely don't see a word
Or hear words
or-
or think words.
like if I hear a word, I'm automatically going to either, if I know the meaning of it, I'm going to visualize it probably,
Mhm.
or not know what it means,
Yeah,
basically.
yeah.
And at which point it will remain an audio sound,
Yeah.
you know?
Let's say you have a concept. Let's say a car. Let's say a concept as a
Mhm,
car.
mhm.
Then you start to see images of cars in your mind.
Immediately already.
Mhm.
I mean, maybe I'm a bit biased that the fact that you kind of activated me to do that.
Sure.
But I can imagine, you know, someone just starting to talk to me like before talking about this, like
Mhm.
for example, if I just try to think of something from before, like for example, when you told me that you're on your way, I think I probably imagined and assumed that you're getting into a train and, you know, maybe you're on the Jubilee line or something like that.
Yes.
And if I say Jubilee line, I already have that. I'm not looking at it in a way, but I have that image in my head.
Yes.
Because I don't really have a need to look at it because I don't
Mm-hmm.
get anything out of it. But if I were to sort of design a software or anything like that or plan something,
Mm-hmm.
I think I definitely, it's easier to put things in place when it's in my mind's eye, you know?
Yes. Yes.
It's hard to do when it's just
So you kind of
abstract
see
concepts.
when you think image, you see like a video play in your head of a certain idea or a certain memory.
Depends what it is. If it is a memory or a feeling, it is going to be more full of motion, I think. But if it is a very abstract thing, it probably will start with an image or something that is static, potentially. I think I might still automatically add movement to it by just moving around the object, even if the object itself is static.
Yes.
So when you started talking about a car, I was visualizing a car with no detail on it, but the concept of a car, but the car wasn't moving, it wasn't on a road or something, but I was orbiting around
Got it.
the image of the, you know, the three-dimensional image.
Prototypical car.
Yeah.
Yeah, with 4 wheels.
Yeah.
With
yeah.
windscreen. Let's
Yeah,
say.
I mean, if you ask me for detail, I'm going to tell you detail because my
Sure.
mind is going to make it.
Yeah.
But I didn't see any detail initially.
Sure.
But I started orbiting around it just to add movement, I suppose.
I see.
But yeah. And it wasn't voluntary. I didn't try to do it.
Yeah.
I just tried to pay attention to what my mind was doing, and that's what I saw. So yeah.
Yes, I'm also mostly thinking images, but more patterns of images. So
Okay.
mathematical patterns,
Okay.
as well as like so for me, like that's why when I was younger, I'm quite good at mathematics because I'm able to see graphs and then spatial representations, and I'm able to grasp it intuitively, where some other people can't.
Okay.
So in psychologists have discovered that 3 different ways that people think, and they think like that for the rest of their life. So it's probably genetics evolve in that.
Genetics as well as early life, I suppose.
Yeah,
Yeah.
yeah, exactly, and personality
Yeah.
connection too. So some a group of people think primarily in words. So by words, I mean by like they hear words. So when they think about a concept, they need a description of that concept. So that in words description. So the reason why, because their left brain is much more dominant in themselves. So their also their skills surrounding language and understanding beginning. So they need that description of a beginning, middle, and end. So what is it? Why is it? Where is it? Kind of a story structure.
Right.
So they need that to think. And then also verbal thinkers tend to talk to themselves as well when they are thinking.
Okay.
So or think to themselves
Yeah.
in words. They speak to themselves basically
Yeah.
in their mind's voice. But visual thinkers, there are two kinds of visual thinkers. So there's object visualizers. So object visualizers are people who see different images and object at once
Right.
when they start thinking something,
Right.
or they see like a movie feeling of like moving images, and then for them like it's difficult to describe to a verbal thinker what they are actually thinking,
Yeah.
because they see like a network of thoughts at once,
Right.
like interchanging, interconnecting at once, and those people tend to be very good like at inventing. They become like very good inventors. So inventors in history like Thomas Edison, Tesla, Leonardo da Vinci, they show signs of even in their notes, like how their notes are very graphic, pictorial,
Okay.
very so they have a lot of drawings, and so they have to be able to image it out, and so that's they see that in their mind's eye, so then they draw it out. But verbal thinkers tend to become more like, they tend to pick journalists. So jobs or professions that focus on language. So journalism, author, writing, things like that.
Right. Or theoretical physics.
No, actually,
No?
theoretical physics is more mathematics. So that's the third visual.
Right. Okay.
Well, second visual thinker, but third thinker overall. So that's a spatial visualizer, they call it. So that's
Right.
different from object visualizer. So spatial visualizers are able to understand the difference between spatial relations, and also able to understand spatial sense more. So they are more aware of their surroundings and things like that.
Okay.
So which is where I tend to fall into. And spatial visualizers also are able to understand abstract connections and abstract concept very intuitively. So like theoretical physics, very abstract, like quantum mechanics, very abstract. But those thinkers, they grasp it all, they get it immediately. You just need to explain a little bit to them, like, and then they see in their mind's eye those spatial connections between them, and they're very good at like geometry, for example, things like that. So, and it started to become interesting because when you have that certain type of thinking pattern, you start to assume that everybody think like you. Like, I mean, just as other things that we were talking about, like colorblind vision, for example, right? So verbal thinker would think that why don't you understand what I'm saying? They say like, why I'm trying to explain this to you.
Yeah.
Why don't you just get it, right? So they're speaking in words. They're assuming that other people will get the word they're saying, but that's not necessarily the case. And then in an opposite way, they see, like verbal thinkers see like notes of like Da Vinci notes, let's say, and it's like nice pictures. But they will not see the interconnected like patterns and objects associated with it. But the object thinker would just know it. Oh, of course, like that's why he's seeing those, because I see like that too in my mind. And then the object thinkers tend to struggle in writing, in describing what they're seeing, what they're thinking, what they're feeling, right? And then spatial visualizers tend to be very good in like technology fields, in mathematical fields, engineering fields. So they're able to so, for example, like they're able to see stress test things. So they're able to know like, okay, what will work, what will not work, right? And stress test between them. So they're very good at doing that in their mind, in the mind's eye.
Cool. And I'd imagine because a lot of the things that you mentioned, it feels like, I've done that before. I've done that before for all the things you mentioned, which makes me think all of the things that you're mentioning, you are obviously inherently, based on your early life, your genetics, and your surroundings, you will be somewhere on the spectrum of that sense.
That's right.
But the more you practice something, the better you'll get with it, because your mind will just start to deal with it more often, get used to dealing with it more often, and
Yes.
essentially be able to interpret that better and better over time, I suppose.
Yes.
So yeah.
Yes.
Cool.
But you can't like accept even with training and
Mhm.
practice, you can't
Mhm.
you can't expect a verbal thinker to suddenly become
Yeah,
very
not suddenly at all, but
not suddenly, but very
slowly.
proficient,
Yeah.
just as much as the object visualizer. They can learn to understand it and think in images
Yeah.
somewhat, but it's not as someone who's really good at it or being born with it.
Yeah.
Right? And
Because at the end of the day,
vice versa.
that person would have had the advantage of time to have done that for so much longer than the other person.
That's right. Yeah.
And so you simply cannot catch up to it, but you can get on to that journey, and it's not impossible to get good with it,
That's
even
right.
though you can't compare yourself to someone who has done it all their life, basically.
That's right.
Cool. Awesome. So I think that would be it for today's podcast. So thank you very much, Ken.
Thank you, Pasha, and thank you for coming, guys. For today's. I hope you learned a lot from our discussion.
Yeah, so we mainly talked about visual. There's a lot more to unpack, and there's a lot more detail we can get into, technical as well as perceptive knowledge of it. But I mean, we can probably come back to it at some point, but we'll probably switch over a few different types of senses and a few other topics as well, potentially guests at some point. So
if you have any questions, please comment down below. And if you have any corrections, if what we're saying is incorrect in some way, please correct us as well.
Absolutely. And we're here to learn, and we're simply sharing our knowledge and experiences, and simply sharing it with everybody else who's watching the podcast or hearing it. So I mean, it's a lifelong learning journey, and so everyone should be open to learning all the time, and here we are. So
and if you're interested in our research, as well as like the personality test for the senses, you can go to our website, pelconsulting.org, and then you can do the sensory test there, and then see what kind of visual thinker you are or visual sense that you like.
Absolutely. Cool. Awesome.
All right. Thank you.
Bye.